Welcome, everyone. This is Professor Richard Holowczak, and this is the Entity Relationship Modeling Lecture, Part 1. If you have been following along with our database system development lifecycle, you will have already followed through the following steps. We begin by identifying a problem or opportunity for the organization. This is typically some issue that an organization has in managing its data. We then gather requirements. This includes interviewing users and collecting documentation. Specifically, with the database development lifecycle, we're interested in requirements that have to do with data. What data do the users want to store, and how do they want to process that data? The next step in the process is to create a conceptual data model, and for that we use the entity relationship model. The entity relationship model, sometimes called ER modeling or ER model, contains 4 components: entities, attributes, identifiers, and relationships. For part 1 of this presentation, we're going to tackle the entities, attributes, and identifiers. We'll save relationships for another lecture. In entity relationship model, the most important thing are entities. Entities are little individual collections of data. Think of it like a subset of the data. We learn about possible entities during the requirements gathering phase of our database development process. Entities are typically given a name that is a noun, and usually this name is one word. Sometimes we have a couple of words for it. We try not to use any abbreviations or punctuation. This is not the time to take shortcuts. Here are some examples of names of possible entities. In a customer ordering system, we might have entities like customers, orders, products, services, invoices, or payments. In a university or a college setting, you might have universities, colleges, buildings, classrooms, students, courses, professors, staff, registrations, and grades. In a doctor's office, you might have doctors or physicians or patients, appointments, procedures, and staff. In inventory management, you might have warehouses, storage locations, inventory, and products. These are just some typical examples of entities that you might come across. Now it's your turn. Read the following example and see if you can highlight what some of the potential entities might be. It takes a little bit of practice. It's not an exact science. So take your time and just jot down on a piece of paper what you think the entities might be in this example. If you like, you can pause the video, and when you resume, we'll talk a little bit about some of the entities. Okay, so here's that paragraph again, and when I read through this paragraph, we're looking for things that might be considered entities, some little collection or subset of the data. A great place to start here is the database should keep track of employees. Employees are a very, very typical entity that you'll find in a lot of databases. The department that they work for. A department could be a separate entity. Each employee reports to a supervisor. Supervisor would be another potential entity. Every 2 weeks, employees turn in a timesheet. Perhaps you're familiar with this. If you've worked someplace, maybe every week or at the end of every 2 weeks or a pay period, you have to fill out a timesheet. So a timesheet would be another entity. And finally, paychecks are issued based on the timesheet. So a paycheck might be another entity. I say that these are possible entities, employees, departments, supervisors, timesheets, and paychecks, because this is not an exact science. It takes a little bit of work and experience to be able to read a paragraph like this and pick out the entities. Don't feel bad if you didn't get all of the ones that I have here. Even I have maybe a little bit of a disagreement about some of them, but that's okay. It's a process that takes time, and it takes quite a bit of revision. If there is any need for clarification, Typically, this is when we would go back to the users where we gathered those requirements in the prior step of the process, and we'll ask them, hey, do these look like the right collections of data? Do you need data about employees and supervisors and timesheets and departments and so on? And this will continue the conversation during the database development process. It is very typical that we will display our entity relationship model with an entity relationship diagram. And you'll sometimes see this abbreviated as ERD, Entity Relationship Diagram. It's basically a picture that is going to show those four elements of entities, attributes, identifiers, and relationships of the ER model. There are quite a few ways or styles that we could use to display an ERD. Depending on which database textbook you use, you could see a variety of different styles. One of the most common is a diagramming style called the Unified Modeling Language, or UML. And that's the style that we'll follow through the rest of this tutorial. In an ER diagram, we typically display entities by simply giving their name and drawing a box around them at the top. Okay, so we have here, here's my employee entity. Whoops, there's an employee entity. Here's my customer entity. Here's a vendor entity. It really is no more complicated than that. As soon as you come up with your list of potential entities, you simply put them in a box, and that's all you need to do. Now, there's a number of different diagramming tools that people can use in order to draw an ER diagram. Here, I'm just using PowerPoint just to kind of keep things simple. Here are some more. This might be for a college situation, a college case, where you have students, faculty, courses, and registrations. So entities are probably the easiest thing to come up with or to spot. It's going to be an iterative process. It's going to take a little bit of time to go through and figure out what the entities are. And that's okay. That's a normal part of the process. The next thing we'll do is we'll look for attributes. Attributes are the properties or characteristics of an entity. We also learn about attributes during requirements gathering. We try to keep the attribute names reasonably short, and we try not to use abbreviations or punctuation. Sometimes we'll use the underscore character if we want to separate the words that are describing an attribute. Some attributes will be provided during the requirements gathering phase. Other attributes are going to be assumed based on our modeling experience. So here's an example. Imagine we have an employee entity. The attributes that will go with this include the first and last name, their street address, their apartment, city, state, and zip code, phone number, email address, and social security number. You can see that these attributes describe the properties or characteristics of an employee. We might ask, what is this employee's email address? Or we want to mail the employee a paycheck. What's their street address, apartment, city, state, and zip code? Maybe if we have an entity called a charity, we might have the name of that charity, the year it was founded, a description of the charitable causes that this charity is involved in. Maybe there's a focus area where they focus their charity efforts, and it might have an IRS designation, and that's a tax designation if they're a 501c3 organization or something like that. If we have an entity called a warehouse, again, we might have a street address. Probably we wouldn't have apartment. Not sure how that got in there. City, state, and zip code. Maybe a building area like the square footage, and possibly a ceiling height. It might be important to know how tall the ceilings are. These are all just examples of attributes. In the Unified Modeling Language, when we want to show our attributes, we simply give them as a list underneath each name of the entity. So for that employee here in the middle, we have our first name, last name, street address, apartment, city, state, zip code, phone number, email address, and social security number. We simply list them below the name of the entity. Typically, this name of the entity is kind of centered in the middle. Mine's a little bit off center. And again, we sort of list these out. Notice we're not using any abbreviations. We're not using any other punctuation. Sometimes we will use the underscore character, like you can see here for student. Yeah, that's pretty much it. It's really no more complicated than that. Again, I would say that coming up with a list of attributes is also going to take a bit of research. We might know intuitively that anytime we see an employee or a student or a professor or a doctor, we know that these are people, and people typically have a first and last name and a place where they live. And that's where we get the street address, apartment, city, state, zip code. And probably we have a way of contacting those people, and that's usually a phone number and an email address. You can also probably think of other things like maybe their Snapchat or Twitter handle or something like that. All right, it's your turn again. Now we've got a slightly revised version of our human resources example. So take a look, read through, and this time, in addition to coming up with a list of entities, see if you can come up with a set of attributes for each of those entities. Again, I invite you to pause the video, write down a couple of ideas, and then when we resume, we will go on and take a look at some of the attributes you could have for each of the entities. Okay, here are some examples for our human resources case. For department, it was suggested that each department has a name and a location, which they suggested would be the city and the state. For a timesheet, we have working hours, overtime hours, and that pay period ending date. Now, it's perfectly acceptable if you were to write this as hours working, or hours overtime, or end date of pay period. That's perfectly acceptable. There's no precise answer when it comes to coming up with a list of entities and their attributes. Under paycheck, we put down the gross amount, the amount of tax, the net amount, the check number, and the check date. Now, you may have noticed in the paragraph there was not a lot written about an employee. It is expected, with a little bit of experience, that anytime you see an example of a person, again, it could be a student, an employee, a worker, a doctor, a patient, anyone, any entity that involves a person, we expect that we will have the first and last name, the street, apartment, city, state, zip code, and a way to contact that person. Again, typically phone number and email address. When you are gathering your requirements and the situation you're working with calls for a customer or an employee or a student, it's assumed that these are the attributes that you're going to add. They don't necessarily have to be explicitly listed. With a little bit of experience, you'll come to know that this is the set of attributes for a person that are going to be part of the entity. Now, let's take a little bit of a side trip and let's talk about what's called an entity instance. And here's how this comes into play. If we look at an entity and its attributes, here I have an entity called vendor. That vendor has a company name, a contact person, a street address, a suite, office suite maybe, city, state or province, a postal code, a country, a phone number, and an email address. If we were to look at each of the attributes and provide a value for each one, we get what's called an instance of that entity. For example, if we fill in for company name, ABC Manufacturing Company, Joe Smith for the contact person, 542 West 112th Street for the street address, suite 102 for suite, and so on. If we fill in all of this data, actual data, for each of the attributes, we would call that an instance. So I would call this the ABC Manufacturing Company instance. And over here, we have a super great supplier company. That's another instance. Sometimes it's helpful to fill out a little bit of data, just as an example. We wouldn't necessarily show this on a diagram. We might just keep this in our notes, and this will give our end users a very, very explicit example of what kind of a data we are going to be storing for them. When they read through this instance, they might see maybe we forgot something. For example, maybe the vendors are still using fax numbers. That might still be a thing. And this will give our users a way to check on our work to make sure that we are modeling all of the data that they require for their case. But there's another reason why I wanted to talk about instances. And that is, depending on the entity and the attributes, it may be important to be able to tell one instance apart from another. And that job goes to the identifier. The identifier is the third important piece in an entity relationship model. The identifier is a special attribute that is used to uniquely determine exactly one instance of an entity. Now that's a very long definition. It sounds a little bit confusing. But if you think about it, how can we tell these two instances apart? Well, you could say, yeah, you have to look at the name, you have to look at the contact person, you see all of these differences, this is how we can tell these two instances apart. The job of the identifier is to make that job really, really easy by simply saying something like vendor ID. Every vendor is given a unique number so that we can instantly tell one instance from another. We don't have to even look at all the other attributes. We can just tell which instance we're looking at by their identifier. Now, there are two types of identifiers that we can come across. The first are called natural identifiers, and these identifiers are attributes that are already present in an entity. You may have noticed, for example, in the employee entity, we had social security number. For trucks and cars and buses, there's a vehicle identification number. And in many tax situations, there might be an employee identification number that maybe the United States Treasury uses to tell employees apart. These are naturally occurring identifiers. They're already part of an entity. And so it's tempting to make use of them as an identifier. The other way we can have an identifier is through what's called an artificial identifier. And we completely make this up. It's usually just an integer, like 1, 2, 3, 4, 5, or 1001, 1002, 1003. It's really just a simple number that has no intelligence or meaning to them. And an easy way to come up with an artificial identifier is simply to take the name of the entity and add the letters ID at the end of it. For example, employee ID, customer ID, student ID, lab ID, room ID, course ID, and vendor ID. I'm going to recommend that when you have an entity and you have your attributes, the easiest thing for you to do is to then add an artificial identifier. Even if the entity already has social security number or vehicle identification number or serial number or some other natural identifier, use an artificial identifier anyway. There's a couple of very subtle reasons why, one of which is that later on in the database management system, we're going to use these identifiers to connect different parts of the database together. And if you use something like a social security number or a vehicle identification number, it's going to become very clumsy and possibly even a bit of a security issue because of how we have to share identifiers in the database. I'll talk a lot more about that in later lectures. So for now, my advice is the easiest thing, just use an artificial identifier and you'll be in great shape. It really is quite simple. If you have a vendor entity, create vendor ID. An employee entity, include employee ID. Even if you have social security number, use employee ID anyway. A charity would be a charity ID, a student would be a student ID. Very, very simple way to create identifiers. It's also good form to list the identifier as the first attribute. Right? Put it right underneath the name of the entity. If you bury it down at the bottom or in the middle somewhere, it just becomes a little more difficult to read the diagram. If it's not obvious that your identifier is an identifier, you can also write the letters ID in parentheses next to it. Here, I don't think we need it because we see vendor ID, employee ID, charity ID, and student ID, so it's not a big deal. We can see this easily enough. All right, we're back at it again. Here's the human resources example. We're going to read through this one more time, and now we're going to show the entities, their attributes, and the identifiers. Again, I invite you to pause the video, make a few notes, and then when we resume, we will see entities, attributes, and identifiers. Okay, here we are. Department, employee, timesheet, and paycheck. This should look familiar from the last time we did this. And all we've done is we've added department ID to department, employee ID, you knew that one was coming, timesheet ID, and paycheck ID. You might be tempted to use maybe the check number or maybe the gross amount or something. It's really not worth it. The easiest thing to do is simply put the name of the entity and then put ID at the end of it. Timesheet ID for timesheet, paycheck ID for paycheck, and so on. That's really the easiest way to deal with identifiers. Now I'd like to talk about some common pitfalls or issues that we might come across when we have entities and attributes. The first one is sometimes we might follow what was written in the case study a little too literally, if you will. For example, suppose we're told that customers have a name, an address, and a telephone number. If you were in a hurry, you might write out customer and maybe the attributes name, ADDR period, and phone with a pound sign there. This is good as a start, but this is not something that would be acceptable in a professional setting. A couple of reasons. First of all, yes, customers have a name, but we know that that name is going to be split into two parts, a first name and a last name. The second, as I've mentioned before, is we don't use abbreviations. This is not the time to start abbreviating. So we would want to write out address completely. And third, we don't use any other symbols like periods or, in this case, the pound sign or the number sign. We don't use those. We write it out with letters, okay? Phone, N-U-M-B-E-R, instead of the pound sign. But even on this one, we can improve a little bit more. Instead of just saying address and expecting to cram the whole address in there, we know that we should expand that into street, city, state, and zip code. Maybe even apartment number as well. I didn't put that one in here. But this would really be the best way to express what we're given here with customers have a name, address, and a telephone number. It's also helpful if you are consistent in using the plural customers as the name of the entity. Here's another situation that sometimes comes up. Instances are really not attributes. So imagine we're given this text. Our t-shirts have different logos. They come in small, medium, large, and extra large sizes, and in colors like red, white, gray, and blue. Now this can be a little bit confusing because you'll see values like small, medium, large, and extra large, but you might interpret those as attributes. This is not the case. Instead of modeling this with small, medium, large, extra large, and the colors red, white, gray, and blue, Instead, we model this as size, which can take on values small, medium, large, and extra large, and color, which could be red, white, gray, or blue. The caveat here is we don't model values, we model the attribute, the characteristic of the t-shirt. So this t-shirt will have a t-shirt ID, it'll come with a logo, it'll have a particular size and a particular color. Here's another one. We try not to use multi-valued attributes. And what does that mean? Well, I mentioned this before. We need to keep track of our employees' address and contact information. We have salaried and hourly employees. If we model this with just address, contact information, salaried, and hourly, we've run into a couple of problems. We're taking what's written here in a very literal fashion. And again, this would be good for a first draft. But when we revise this, we know that anytime we talk about an address, we really want to see street, apartment number, city, state, and zip code. When we're asked about contact information, we know that that should be something like phone number and email address, maybe even the phone extension. Sometimes you'll see that is asked for in some databases. So that's where we would get our contact information, and more if we need it. And finally, we have salaried and hourly employees. That's more like the type of pay that an employee gets. And so the way we can model this is by having a pay type, which would take on the values of salaried or hourly. We can have a pay rate and a pay time period. If an employee is an hourly employee, they would have a pay rate that's a certain dollars, and the pay time period would be per hour. If they are salaried, we would have a salaried pay type, and the pay rate would be a certain number, and the pay time period might be annual. So this is how we can model both salaried and hourly employees. Okay, we're at the end. I'm going to leave you with one more practice case study, and this is the firehouse. So take your time, read through this case study, and see if you can write down the entities, attributes, and identifiers for the following business case. Once you're all done, you can resume your video and you can see what I have listed on the last slide. Okay, here are the results, and you can again take your time, maybe flip back and forth a little bit and see how we have mapped what was given in the business case to this set of entities, attributes, and identifiers. All right, that's all the time we have for today. Thanks for your attention, and look for the Entity Relationship Modeling Lecture Part 2 coming soon.